Here we go. We're doing the review on similarity. We're in Unit 8. In the diagram below, it's telling you that triangle ABC, this symbol right here means similar to triangle EFG. And remember that symbol means angles are congruent and all the sides are in the same proportion. So when it says that angle C is 120 degrees, well, right away, C is the last letter, G is the last letter, which means angle G is also 120. Angle F is 15 degrees. Well, if angle F is the middle letter, then the middle letter of this triangle, angle B, is also 15 degrees. So in part A, when it says determine the measure of angle E, I know angle E and angle A are going to be the same because they're the first letters in each of these triangles. So I know that the three angles of any triangle add up to 180 degrees. So right now I have 120 degrees and 15 degrees, which is 135. I subtract that from 180 degrees and I get 45, and that's equal to the measure of angle E, which is also the measure of angle A, just in case they asked. So then they also told me that side AB is 20 and side EF is 10 and side AC is 8. So in part B, it says using a proportion determine the length of segment. That symbol above EG means segment EG. So I'm going to set up a proportion that compares corresponding parts. So I'm going to start with 20 over 8, which is the long side over this base, which means I have to just compare the same parts. There's a whole bunch of different ways you can set up this proportion, and they would all be correct. But when we solve a proportion, we're going to cross multiply. And when we cross multiply, we get 8 times 10 is equal to 20 times x. The product of the means is equal to the product of the extremes. That's how we get rid of our fraction. So 80 is equal to 20 times x. The opposite of multiplying by 20 is dividing by 20. And 80 divided by 20, the last time I checked, was 4. And that's the length of EG. All right, here in number 2, it says in the diagram below, triangle ABC is similar to triangle ADE, so the same rules apply. All angles are congruent and all sides are in the same proportion. Which measurements are justified, meaning which is true? So they give us the length of AD, and by the way, I highlighted the two triangles. You're always comparing full triangle parts to full triangle parts. So AD is the triangle in yellow, that's the left side, and AB is the left side of the orange triangle. AE is the right side of the yellow triangle, and AC is the whole right side of the orange triangle. So what we're going to do is we're going to set up a proportion comparing those parts. So AD is the left side over AB, the left side, and we want to know, is that congruent to, now we're going to compare the right side of the smaller triangle to the right side of the larger triangle. And when we cross multiply, 5 times 10 is 50, and 8 times 7 is 56. That is not true. So what we're going to do is we're going to set up the same proportions for parts B, C, and D. Pause the video, set those up, come back here, and let's check our answers together. Okay, so what I did is I drew the triangles out for parts B, C, and D, and then I set up a proportion. So 3 over 9 equals 5 over 10. And when I cross multiply, 45 does not equal 30. So the answer is not choice B. Then when I did part C, I did 2 over 6 equals 5 over 15. 2 times 15 is 30, and 6 times 5 is also 30. That's the answer, but let's keep going just to make sure. 4 times 6 is 24, and 3 times 12 is 36, so that's not true. So the only true proportion is letter C. Great job, guys. Okay, number 3, using the information given below, which set of triangles cannot be proven similar? So what I did is I redrew this triangle over here so that all the corresponding sides are going to be in the same positions. So when I set up my proportion, 4 over 3, the left side over the base, equals 12 over 9, the left side over the base. It's a question. Well, when I cross multiply, 3 times 12 is 36, 4 times 9 is also 36. And as you can see here, I have this side, the right angle, and this side. So this is the side angle side method. Okay, down here it shows me that these two angles are congruent and these two angles are congruent. So these two triangles are similar because when you have two angles of one triangle congruent to two angles of the other, then the third has to be true as well. So that is also another method of proving triangles congruent. Up here, I'm going to redraw this triangle like I did over here, so all the corresponding sides are in the same spot. I'll be right back. Okay, so as you can see, I just redrew this so that the angle J is in the same spot as angle G, and this way K corresponds to H and I corresponds to F. So now I can set up my proportion. I can say this top side 2 over this slanted side 8 is equal to the top side 16 over the bottom side of 32, and it's a question. And when we cross multiply, 8 times 16 is 128, and that does not equal 32 times 2, which is 64. But we can also look here. This is an angle here, and then they gave us side. So this is a side angle, and that does not prove that triangles are similar. And choice 3, we have here again, this side is congruent to this side, this angle is congruent to this angle, and these two sides have the same measure as well. So this is going to be the same method here without the numbers. This is the side angle side method, which does prove triangles similar. So the answer is choice 3. Side angle does not prove triangles are similar. Okay, here's number 4. It says in the diagram below of triangle ABC, points D and E are on segment AB and segment CB. Notice how I read that symbol, respectively. It just means in that order. Such that segment AC is parallel to segment DE. Well, what that tells us is that this angle A and this angle D are congruent. They're called corresponding angles, which means angle C is corresponding congruent to angle E, and they both share angle B. So therefore, all the angles of the two different triangles are congruent, which means the triangles are similar. So if AD is 24, now remember, AD is the side of actually this trapezoid, okay? So we're not actually going to use that 24 in our problem. We're going to use it to find the length of the full triangle side. Side DB is 12, so I'm going to put a little line up here to say 24 plus 12 equals 36, and that's the length of side AB. They're telling us the length of DE is 4. Using a proportion, determine the length of side AC. So I'm going to pause the video for a second. I'm going to highlight my two triangles. Okay, so hopefully this helps you out a little bit. So what we're doing is we're looking for side AC, which is the side of the orange triangle. What other side do we have? The full side AB, that entire length of the orange triangle. So what do we have to do? We have to compare the same parts. So the base AC is going to be compared to the base DE, and then this top side AB is going to be compared to the corresponding side of DB. Now we're going to fill in the numbers, and then we will cross multiply and solve. So x over 36 is equal to 4 over 12. Okay, and then when you cross multiply, and again, you can always pause the video and you can try out all these numbers on your own and then come back and check your answers. That's actually the best way to do this. The opposite of multiplying by 12 is dividing by 12. So you get your final answer. X is equal to the length of AC, which comes out to be 12. All right, number 5, I'm actually going to redraw these triangles so that both triangles are sitting upright, and angle R is congruent to angle X, S is congruent to Y, and T is congruent to Z. All right, so I'll be right back with that. Okay, so now angle R and angle X are in the same spot, angle S and angle Y are in the same spot on the left, and then angle T and angle Z are in the same spot. So now all my corresponding sides are in the same spot as well. So if RS is 6 and ST is 14, XY is 9, okay, which is also over here, but now I know that the 9 and the 6 are the corresponding sides. It says YZ is 21, that's over here, it's also over here. Now I know that these two sides are corresponding. And it says angle S is congruent to angle Y, okay, so look what they're giving us, side, angle, side. Are these two triangles similar? So if they are similar, the sides are going to be in proportion. So now we're going to set up a proportion, and then we're going to solve it. So I'm going to take 21 over 9, and I'm going to say, is that congruent to 14 over 6? And when we cross multiply, 9 times 14 is 126, and 21 times 6 is also 126. So justify your answer. If the triangles are similar, state which simile method. So it's yes, the triangles are similar by side, angle, side, right? Side, angle, side, and the corresponding sides are in proportion. Okay, so here it is. Yes, the triangles are similar by the side angle side method, and the corresponding sides are in the same proportion. So again, pause the video, write down what you need to, and then come back and meet me at number 6. Okay, so I marked up my picture a little bit. It gave me all the information that the triangles are similar, which means the angles are congruent. All the sides are in the same proportion. They told me AC is 12, DC is 7. Those are your corresponding sides, right? A and C are the first 2 letters. DC are the last 2 letters. They gave me the perimeter of triangle ABC, and they're asking me for the perimeter of triangle DEC. So we're going to compare sides to the perimeters. Okay, so I am looking for the perimeter X, and I have the side of 7. So in the other triangle, you have to compare the same parts. The perimeter is 30 and the corresponding side is 12. So pause the video, do the work, come back and check your answer. So you may have set up your proportion differently, but when you cross multiplied, you should have got 12 times x equals 210. The opposite of multiplying is dividing by 12. And you should have gotten your answer to be 17.5. Great job. I'll meet you on the next page. All right, so I got us started. It talks about a summer camp counselor wants to find the length of X, which is the feet across the lake represented in the sketch below. I redrew my triangle so that the corresponding sides are all in the same spot. So angle B is in the same spot. Angle D, which has 1 arc, is equal to angle E, which has 1 arc, which means angle C should be up here. So now these are the corresponding sides in the same spot. It says AB is 1,800 feet. That came first. EB is 1,400 feet. BD is 700 feet and CD is 800 feet. And then I labeled appropriately. You should pause the video and write that down on your own. And it's telling you that these 2 angles, AEB and CDB, have the same measures, and use a proportion, find the value of X. So I'm looking for AE, which is X. I have the length of EB of 1,400, and then we're going to compare the corresponding parts. Side CD is 800 and side DB is 700. Pause the video, do the math. I'll meet you right back. All right, when you cross multiplied and you divided by 700, you should have gotten 1,600 feet. All right, number 8 is asking you to prove whether or not the triangles are similar. So once again, pause the video, set up your proportion, and then come back and check your answer. I'll give you a little hint. Make sure that you're comparing the left side of the little triangle 3 to the whole left side of the big triangle, which is 13. And we want to know, is that equal to the right side of the triangle to the whole right side? So did you get 27 does not equal 26? Great job. The triangles are not similar. The corresponding sides are not in the same proportion. Pause the video, write it down. I'll meet you on the next page. Given the diagram below, it's asking, is triangle ABC similar, remember angles are congruent, all sides in the same proportion, to triangle DEC? So what most people like to do is they set up the proportion 20 over 12, and then they'll do 3 over 5, which is incorrect because angle A is going to be congruent to angle D if these are in proportion. So what I like to do is redraw this triangle so that angle A and angle D are in the same spot. Angle B and angle E, the second 2 letters, are in the same spot. And then angle C is obviously also in the same spot. So now when I do the top 20 over the bottom side 12, I know that the top length of 5 is going to be similar or in proportion to the bottom side of 3. These are the sides that are corresponding. All right, so solve it and let's come back and check our answers together. Are these 2 triangles similar? So you should have gotten that 60 is equal to 60. So the answer is yes. The triangles are similar by the side angle side method. The corresponding side lengths are in proportion. And now we're going to move on to the last question, which is the proof. And every proof starts with rewriting the given information. So remember, I'm going to talk a little bit faster than you're going to be able to write. So always pause the video and go back where you need to. So from the given information, we know that this symbol means parallel. It says that GI is parallel to segment NT. And we know that if 2 parallel lines are cut by the transversal, then the alternate interior angles are congruent. So angle I is going to be congruent to angle N. And in order to prove triangles are similar, we need to have 2 congruent angles. So you can also say angle G is congruent to angle T, you'd be done. If you didn't see that, you could have also stated the vertical angles. If 2 lines intersect, then the vertical angles are also congruent. So you could have said angle 1 is congruent to angle 2, and that would have been your 2 angles. So no matter how you do it, You get the triangles are similar by angle, angle, congruent to angle, angle. You guys are doing a fantastic job. Keep up the great work. See you soon.